Hi everybody, we are looking at section 3, properties of logarithms in the unit on exponential and logarithmic functions, and we are diving into example 2, which will also bring us to what we know as the quotient property. In the last video we just talked about the product property, so the quotient property stems from the property of exponents where you have something like b to the m over b to the n equals b to the m minus n. So when you're dividing like bases, we subtract our exponents. So how does that translate into logarithms, you might be wondering? Well, the log of the quotient m over n, log base b, will equal the log, keeping that same base, so log base b of m minus log base b of n. Since subtraction and division are not commutative, the order in which we do these operations does matter, right? We can't just do things in whatever order we feel like it. We have to subtract in a specific order, just like we have to also divide in a specific order. So we will always start off with the essentially the numerator out front and then the denominator as the second part. Something to keep in mind going forward is when you have log of one thing minus log of another thing, and maybe you have minus log of another thing, anything that will have a minus sign in front of it, those components are going to be linked to your denominator. That's very important. I'm planting the seed. This is foreshadowing for examples to come in future assignments, or in future examples. Okay, so tuck that into your brain, save it for later. Let's go and do some examples. So we're going to be example 2, using the quotient property. Use the quotient property. Again, I changed it to property from rule. I explained why in the most recent video, to expand each logarithmic expression. So let's get into this one over here. All right, so for this first example, I have the quotient 19, which is prime, over x. So that's going to be log base 7 of 19 minus log base 7 of x. And that is it. 7 is a subscript. It is below everything else. There are no exponents in this situation, so nothing is above anything else. Log, 1, 9, log, and x are all along the same line where you would normally print your name. Okay, that's it for that example. Let's look at the next one. So this one is done. And let's actually circle our final answer. All right, so here, next example, I have natural log, ln, right? ln is the natural log, comes from Latin, logarithmus naturalis, and it's in Latin-based languages, the adjective comes after the noun, and that's why, it's described as log natural in a sense, and the way we speak, we say natural log, so the abbreviation seems weird, but that's what it is. And the natural log comes from our natural growth factor, our natural growth base, E, Euler's number. So log base E is ln. All right, so let's keep all that in mind while we go ahead and do some of these examples. All right, so here I'm going to go ahead and expand using the quotient property. So I'm going to start off with the ln of e to the third, and pay attention to how I say things as well, okay? Because the way you read something off will display whether or not you have an understanding of what you're doing. Now, this over here, like I said, since the ln is really the log base e of, and we have e to the third, and we saw in section 2, the property log base b of b to a power equals the power. And if we wanted to read this off, e to what power equals e to the third? Well, the answer to that is 3. So I can simplify this further, similar to how I was able to use the common log base 10 to simplify example B for the product property. So this actually will equal 3 minus ln 7, and there is nothing I can do to simplify further than that, and this one is finished. Finito. Next example we can do, let's look over here. log base 8 of 23 over x. So again, very simple. It's going to work just like example A above. So it's log base 8 of 23 minus log base 8 of x. And there you go. All done. And last we have this one over here. And I have the ln of e to the 5th power minus the ln of 11. Then, oh, maybe I shouldn't do it that way. Similar to the last example, ln is log base e, so e to what power equals e to the 5th? 5. 5 minus the ln, or natural log of 11. And we're done. Now we can combine these properties, product and quotient properties, to make for busier examples, and then we could also tie in another property called the power property, and that's what we're going to see in the video for example 3. So if this is all right, you can grasp this, you're following, and you can memorize and understand what to do in these cases with natural log and e. Very, very important concept. I cannot stress it enough. It does not go away. Then go ahead, give a thumbs up. If not, thumbs down. Questions, comments, concerns, feedback, and requests, go in the comment section below. Check out the playlist on the screen right now, and check out the description box. And bye for now. Adios.